Hi GOR, this is Unit 4, Lesson 2, and today we're going to talk about dilations on the coordinate plane. You're going to see that it's nice and easy to do. Just a quick reminder, a transformation is a change in the position, shape, or size of a figure. So based on that, a dilation is a transformation. A rigid motion is a transformation that changes only the position of the figure. Remember, length and angle measure are preserved. Is a dilation a type of transformation? Absolutely. To be a transformation, it's a change in the position, shape, or size. A dilation is a transformation. It's a change in the size. I might be making it smaller. I might be making it bigger. Is a dilation a rigid motion? Let's look at the definition. To be a rigid motion, I change only the position of the figure. Length and angle measure are preserved, kept the same. Is a dilation a rigid motion? No, it's not, because the length is not preserved. A dilation changes the size. It is not a rigid motion. Length is not preserved. Okay, in the last lesson that we did yesterday, just to make sure that everybody understands that, when you're dilating, the figure gets larger or smaller. The sides are all in proportion. The angles are the same. And we had something called the scale factor. The scale factor determines if it's going to get bigger or if it's going to get smaller. If the scale factor is 3, what happens to the sides? They're 3 times as big, so it gets bigger. If the scale factor is 1/2, what happens to the sides? They get smaller. And if the scale factor is 1, it stays exactly the same. So we saw from yesterday that when we had that scale factor, we were actually multiplying each of the sides by that scale factor. So based on the observation of what we just talked about here, what operation is used with dilations, and that is multiplication. Dilations is another transformation that you don't need to memorize the rule. You're just going to multiply by whatever the scale factor is. How does it look with notation? So we have D. Usually we have an O for origin, and that K is the scale factor. So that's what I multiply. So when I have a scale factor of K, I take K and I multiply it by the X coordinate, and I take K and I multiply it by the Y coordinate, and that is my answer. So O stands for the center of dilation. It's usually the origin, and K is my scale factor. So I wanted to show you a graph that was already done for us. So given triangle DEF with the center of dilation at the origin and a scale factor of 2, plot D prime, E prime, F prime. So D is 0, 4, E is 1, -2, and F is -4, 2. As I said, this is already done for us. All you do is you take each of the points, okay, this is the pre-image right there, and you multiply the X and the Y by 2 because my scale factor is 2. So the scale factor is 2. Everything gets multiplied by 2. So D was 0, 4. 2 times 0 is 0. 2 times 4 is 8. E is 1, -2. 2 times 1 is 2. 2 times -2 is -4. F was -4, 2. 2 times -4 is -8. 2 times 2 is 4. So you can see the original points are graphed and the new points are graphed. They are 2 times further away from this origin, from this center, as the original points. All right, the figure is 2 times as big. If I took out a ruler and I measured D prime, F prime, and I measured DF, it's 2 times as big. Every single side is 2 times as big. The angles, however, are congruent. Angle F is congruent to F prime. Angle D is congruent to D prime, and angle E would be congruent to E prime. All right, let's try one together where we have to actually do it. So I'm going to graph triangle NAP with vertices. N is 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. There we go. So that's N. A is -6, 0. 1, 2, 3, 4, 5, 6. And P is 4, -2. So this is NAP. And I connect them. And I'm going to do a dilation, okay? I want to graph and state the coordinates of n prime, a prime, p prime after a dilation of 1/2. So all I'm doing is taking each of the points from the pre-image and I'm multiplying by 1/2. So n, I'm multiplying 1/2. 2 times 1/2 is 1, and 1/2 times 8 is 4. Taking a half of each point. A is -6, so half is -3. Half of 0 just stays 0. P is 4, -2. Half of 4 is 2. And half of -2 is -1. I'm going to plot these points. Now I multiplied by 1/2, so this should be getting smaller, be reducing in size. It's getting closer to that point, that center of dilation. And there is my image right there. All right. Now what happens if it's not centered at the origin? So I have an example right here, and it's already been drawn for us, but so I have D is 1, 2. That's the point. I'm dilating it about this point in the middle, point D. All right. Triangle A prime, B prime, C prime is the image of triangle ABC after a dilation of scale factor 2 centered at point D. How could we find these coordinates if they were not given to us? So pretend A prime, B prime, and C prime is not there. How could I do it when it's not centered at the origin? I can't just multiply each of the points by 2. That's not going to work. But here's what you can do. If you remember back from geometry when we talked about slope, how far away is B from this point of dilation? See how I go over 1 and up 3? I'm just going to do that one more time. Go over 1 and up 3. So that's how I can find it. It's twice as far away. B prime is twice as far away as B from that point in the center. And I'll do the same thing for A. To go from this point to A, I went down 1 and 1, 2, 3, 4 and over 4. So I'm going to do the same thing, down 1 and over 4. So it's twice as far. If my scale factor was 3, I would do the same thing one more time. I would be 3 times as far away from it. And then I would do the same thing for C. So how far away is C from D? Well, I go down 1, 2, 3 and over 1, 2, 3. So same thing, down 1, 2, 3 and over 1, 2, 3. So if those points were not there, you're sort of using the slope to figure that out. Okay, so you're just counting. You're using the slope, or you're counting how far the point is from D, and you want to go twice as far. All right, let's do a composition so you can see what that looks like, and that'll be the last one for today. So A is the point 1, 3. B is the point -2, 2. And C is the point 0, -2. So I'm going to graph and state the coordinates of the image A double prime, B double prime, C double prime after a composition. Now remember, when I have a composition, I have two things that I'm doing. I always do the thing on the right first. Okay, so first I'm going to do my translation of 3, -2. So that means a translation is that other, that's a nice, translation is easy in that you're just adding. You don't have to remember any rules. So 1 plus 3 is 4. 3 plus -2 is 1. -2 plus 3 is 1. 2 plus -2 is 0. And 0 plus 3 is 3. -2 plus -2 is -4. And then I'm going to do my dilation of 2. That will be my final image. So dilation of 2, that 0 is just saying I'm dilating it from the origin. That means all I have to do is multiply both points by 2. So 4 times 2 is 8. 1 times 2 is 2. Now let's do B prime. 1 times 2 is 2. 0 times 2 is going to stay 0. 3 times 2 is 6. Negative 4 times 2 is negative 8. And then I would just graph these points. It said to graph and state the coordinates of the image. So here are the points, and I'm going to graph them. So 8, 2 is right there. 2, 0 is right here. That's going to be my B double prime. And 6, 2, 3, 4, 5, 6, negative 8 is going to be right there. Now I didn't draw my